Nearly 1 million miles from Earth, the James Webb Space Telescope drifts silently through space. Protected by a giant sunshield and operating in the cold darkness far from our planet, it serves as humanity's most powerful window into the distant universe. Unlike ordinary telescopes, Webb is designed to detect faint infrared light. This ability allows it to see objects so distant that their light has traveled for billions of years before finally reaching its mirrors. Every image it captures is more than a picture of space, it is a glimpse into the past. Because light requires time to travel, looking deeper into space means looking farther back in history. Some of the light collected by Webb began its journey long before Earth existed. These ancient photons carry information from an era when the universe was still young and many of the structures we see today had not yet formed. One of Webb's greatest achievements has been its ability to observe galaxies that appeared surprisingly soon after the Big Bang. Astronomers expected the earliest galaxies to be small, simple collections of stars. Instead, many observations have revealed systems that seem larger, brighter, and more developed than predicted. Some of these ancient galaxies already contain enormous numbers of stars and significant amounts of heavier elements. This discovery has sparked excitement among scientists because the first universe contained mostly hydrogen and helium. Elements such as oxygen, carbon, nitrogen, and iron were created later inside stars. For those heavier elements to exist, stars must first be born. They then spend millions of years producing new elements through nuclear fusion before eventually releasing those materials back into space. Finding evidence of such elements in very early galaxies suggests that this cycle happened far more quickly than researchers once believed. This means the young universe may have experienced periods of intense activity. Massive stars could have formed rapidly, burned through their fuel at incredible rates, and exploded as supernovae. Those explosions would enrich surrounding clouds of gas, allowing new generations of stars to form with increasingly complex chemistry. In a relatively short cosmic time, regions of space may have transformed from simple clouds of hydrogen into environments rich with the ingredients necessary for planets and, eventually, life itself. Yet Webb's discoveries are not limited to distant galaxies. The telescope has also examined strange objects much closer to home. Among these are brown dwarfs, mysterious bodies that exist between planets and stars. Brown dwarfs are larger than most planets but lack the mass required to sustain the nuclear fusion that powers stars. For years, they were thought to be relatively simple objects. Webb's observations have painted a different picture. Scientists have detected water vapor, methane, and other complex molecules in the atmospheres of certain brown dwarfs. They have also found evidence of powerful weather systems, with clouds forming and shifting across their surfaces. Some appear to experience storms that may dwarf anything seen in our own solar system. Even more intriguing are signs of magnetic activity. Certain brown dwarfs display glowing atmospheric features similar to auroras on Earth. These luminous displays suggest the presence of powerful magnetic fields interacting with charged particles. Researchers believe that in some cases, an unseen companion object could be influencing these magnetic phenomena. If confirmed, such discoveries would demonstrate how astronomers can detect hidden worlds indirectly through the effects they produce. The James Webb Space Telescope has also transformed the study of exoplanets, planets orbiting stars beyond our solar system. Before modern telescopes, planets around distant stars remained largely invisible. Today, scientists can analyze the light passing through an exoplanet's atmosphere and identify the chemical compounds present within it. Using this technique, Webb has detected water vapor, carbon dioxide, methane, and other molecules in several alien worlds. These measurements help researchers understand how planets form, evolve, and interact with their environments. Some exoplanets have proven remarkably different from anything found in our solar system. Certain giant planets follow highly elongated orbits, carrying them close to their stars before sending them back into deep space. Such unusual paths suggest dramatic histories involving powerful gravitational encounters. Interactions with neighboring planets or companion stars may have reshaped entire planetary systems. These observations reveal that planetary systems can be far more chaotic than the relatively stable arrangement we experience around the Sun. In some cases, Webb has helped scientists study planets that appear to be slowly spiraling inward toward their parent stars. As these worlds move closer, immense gravitational forces stretch and heat their atmospheres. Over time, material may begin escaping into space. Eventually, some planets could lose significant portions of their mass or even be completely consumed by the stars they orbit. Such events remind us that planets are not permanent fixtures. Throughout the universe, worlds are constantly forming, evolving, and disappearing. The telescope has also observed vast disks of gas, dust, rock, and ice surrounding young stars. These structures represent the earliest stages of planetary construction. Within these disks, tiny particles collide and stick together. Over millions of years, they grow into larger and larger bodies. Some become asteroids, comets, or moons. Others may eventually develop into fully formed planets. This process is not smooth or orderly. Collisions are common. Objects are scattered, shattered, and rearranged by gravity. Yet from this apparent chaos emerge entirely new planetary systems. Studying these regions provides valuable insight into how our own solar system may have formed billions of years ago. As Webb continues its mission, another important theme has emerged. The universe appears far more dynamic than scientists once imagined. Galaxies collide and merge. Stars are born in enormous clouds of gas and later explode in brilliant supernovae. Black holes grow by consuming surrounding matter. Planets migrate through their systems, sometimes surviving and sometimes meeting destructive ends. Far from being static, the cosmos is a place of constant transformation. Yet there is something remarkable hidden within this cycle of creation and destruction. The same processes that destroy stars create the elements needed for future generations of planets. The explosions that scatter material across space also provide the raw ingredients from which new worlds can form. Everything on Earth is connected to this cosmic history. The oxygen we breathe, the carbon in our bodies, and the iron beneath our feet were forged inside stars that lived and died long before the sun was born. In a very real sense, every human being carries material that originated in ancient stellar furnaces. This connection gives Webb's discoveries a deeper meaning. The telescope is not simply exploring distant objects. It is helping us understand our own origins. Every new observation adds another piece to the story of the universe. Some discoveries confirm existing theories, while others raise entirely new questions. Each answer reveals additional mysteries waiting to be explored. As the James Webb Space Telescope continues gathering light from the deepest reaches of space, it reminds us that the universe remains an unfinished story. Across billions of years and trillions of miles, countless secrets still await discovery. And with every photon captured, humanity moves a little closer to understanding its place within the vast cosmic ocean.